Hello dear students, in this lesson we are going to learn really powerful tools to work with multiple threads and to manage all threads. In this lesson I will explain you the concepts of executors. We'll review Executor and ExecutorService interfaces. You will learn what a thread pool is. Today we are going to have a lot of examples and you will see how you can start threads with ExecutorService. Also, today we will learn what a callable interface is and what future type is. And at the end of the lesson we'll learn how to interrupt all threads in ExecutorService properly. And as I already said before, today we are going to have a lot of examples. Let me start screen sharing and we'll learn with you this topic by reviewing source code and examples. I open Executor interface. Let's understand first what this type is about and why do we need it. Objects of Executor type execute submitted runnable tasks. This interface provides a way of decoupling task submission from the mechanics of how each task will be run, including details of thread use, scheduling, etc. An executor is normally used instead of explicitly creating threads. For example, rather than create a new thread object, pass runnable as constructor argument and call start method for each task, you may use execute method of executor type. So, as you can see, this interface declares only one method, execute, that takes runnable. Executors are capable of running asynchronous tasks and typically manage a pool of threads, so we don't have to create new threads manually. Probably this is the first time in this course when I mention thread pool. What is it? A thread pool is a software design pattern in multi-threading programming. Thread pool maintains multiple threads waiting for tasks to be allocated for concurrent execution by the supervising program. By maintaining this pool, the model increases performance and avoids latency in execution due to frequent creation and destruction of threads for short-lived tasks. Because creation of a thread object also takes some time. And why I should create 10,000 threads for 10,000 tasks that are relatively small and fast? It would be a great idea to reuse threads that were created already for new tasks, agree? But how much threads we need to create initially? We'll get back to this question later. All threads of the internal pool will be reused under the hood for relevant task, so that we can run as many concurrent tasks as we want throughout the lifecycle of our application with a single executor. There is another popular interface that extends this one. It is called ExecutorService. And to be honest, there is not so much popular direct implementations of Executor interface. More often we'll use implementations of ExecutorService interface. Let's try to understand what is the difference between these two types and why we need ExecutorService. This type introduces new behavior. With help of ExecutorServices, I may manage termination of all threads and not completed tasks. And in addition to that, we can submit tasks for execution that will return us future object. We will be able to get the result of computation by a separate task in the future. Here in method outline you can see group of methods that allow us to terminate all tasks properly. I will show you in a few minutes how to work with them. We have submit method that allows us to submit tasks for execution. I can submit both types, runnable and callable. I will also explain what callable type is in this lesson. Also, we have a group of methods to manipulate with group of tasks during the task submission. I'm talking about invokeAll and invokeAny methods. Let's jump from source code of interfaces to code examples. I have a separate package here that is called executors. It contains all examples related with executors and executor services. I open our first example. The class name is execute with executor service. In main method I create our first executor service. How to create it? We have factory methods in executors class. If we open executors class source code, you may find a lot of static methods that return the reference to the executor service. These factory methods are started with new word. We will learn with you the difference between different implementations of executor services. But at this moment, let's start from the simple things. Let's get back to the demo file. One of the most popular executor services is a cached thread pool. I create the object of executor service here. After that I call execute method and pass the runnable. Simple runnable that just prints thread name to console. And I can execute another task in similar way. Let me run the program now. And in console you may see name of the thread from our cached thread pool. Probably you won't ask me right now, Andrey, are you kidding with us? This example is much simpler than creating a thread and starting a thread. Please, don't think like this. This is easy for you because you already understand what is happening under the hood. We'll keep learning new things, and you need to understand how thread interruption is happening, what state thread has, what daemon threads are, how priorities impact thread scheduler decisions, and many other things. You just need to understand this. Let's move on. Let me now explain what a callable type is. Callable is a functional interface that declares one method, call. Pay attention that callable is a parameterized type and call method returns value of a parameterized type. Also, call method may throw exception. This is also an important difference between call and run method from runnable. If you remember, run method returns nothing and has return type void and doesn't throw exception. That's why we need to handle all checked exceptions inside run method. But we can throw to upper level exception from call method. Now I open callable demo. I create ExecutorService, and to submit task that has callable type, we have to call submit method. Execute method only takes runnable, but submit method is overloaded and may take either callable or runnable. In this case, with the lambda function, I implement contract of callable interface. If you are not familiar with lambda expressions, I recommend you to complete my functional programming course for Java engineers. At the meantime, we proceed. So in this case, callable should return the value as a result of addition. Submit method returns as reference to the object of type future. What is it? The object of this type represents the result of an asynchronous computation. Methods are provided to check if the computation is complete, to wait for its completion, and to retrieve the result of the computation. Let's review what methods we have here. Cancel method with Boolean flag. The method attempts to cancel execution of this task. This attempt will fail if the task has already completed, has already been cancelled, or could not be cancelled for some other reason. Boolean flag here is to indicate whether we want to interrupt tasks that are in progress and not completed yet. To achieve this, we need to pass true value here. Or we want to interrupt only tasks that are not started. In this case, we need to pass false here. Is cancelled. I believe that this is self-describing method. Returns true if task has been cancelled before it completed normally, and false otherwise. Is done. Returns true if task was completed and false otherwise. Get. This is a key method of future type in my opinion. Pay attention that this method blocks thread of execution until computation of task will be completed. That's why this method may throw interrupted exception, in case thread will be interrupted while it waits result of a task. And potentially, this method may throw execution exception, in case some exception will happen during the task execution. Get method is overloaded, and we have get method that takes first long argument and time unit. I love this method because it allows me to not block thread constantly waiting for result. You can tell wait result of computation, for example, 10 seconds, and after that, proceed with thread execution. Additionally, this method may throw timeout exception if the wait timed out. Let's get back to our callable demo and proceed with our example. Now I wanna print to console result of task computation. I call get method with timeout. Let me run this app. And in console I can see result that was returned from the future object. Can you understand now how callable works? Now when you know callable type, let's proceed learning executor services. I'd like to review with you invokeAll and invokeAny methods and how they work. I open invokeAll demo file. I create executor service. After that, I create a list of tasks. I can use executor service to submit multiple tasks at once. InvokeAll has overloaded version with timeout. So this method may return results when all complete or the timeout expires. whichever happens first. invokeAll may throw interrupted exception. That's why you need either to handle it or to let other know that this piece of code may throw interrupted exception. Let me run the program. And I see in console results of each task. Pay attention that invokeAll method returns list of future objects. In our case, future is parameterized by string. I create a stream from this list and apply function to each future object that retrieves value from it. And I print all values to console. Basically, that's it. I believe you feel relief that you don't need to create a new thread object for multiple tasks. You don't need to call start method on each thread. As you can see, starting multiple threads much easier with executor services. The next example is invokeAny demo. The precondition is similar to the one I had in invokeAll demo. I have a little bit different tasks here. Each task sleeps different amount of milliseconds, and afterwards I call invokeAny method on my executor service. I don't have list of features returned. Return string value. This is a result of completion of the task that was completed first. Let me run the program. And it doesn't matter how much I would run this app, I would get the same result. Why? Because the task number 2 has the shortest sleep timeout, and it will be always completed as the first one. This method also has overloaded version with timeout. In case timeout will be over before any task would be completed, timeout exception will be thrown. invokeAny may throw interrupted exception and execution exception. Execution exception will be thrown if no task successfully completes. Do not forget about this. Now let me show you the next example. I will show you how nice and elegant you may interrupt multiple threads. I open executor service interruption demo file, and here we have our next example. I create executor service and submit different tasks here. I use instStream to generate stream of values from 0 to 9, and for each I perform the next operation. I submit task for execution. Task contains sleep for timeout in seconds. Pay attention that sleep interval is different in each task. The longest sleep timeout is in the last. And now, when we submitted all tasks, let's focus on threads termination. Why we need to shut down our executor service. Executor service manages threads and process tasks when there are any. But in case your app is finished, JVM may still work because executor service will not be automatically destroyed, and waiting executor service may keep JVM running. So how to close all threads that are managed by executor service? The rule of thumb is to follow the next algorithm. The first thing we need to do is to call shutdown method on executor service. Shutdown method makes executor service stop accepting new tasks and shut down after all running tasks will be finished. So theoretically, you may just call shutdown method and let executor service finish its job, and that's it. In case you will try to submit any new task after we called shutdown method, you would get rejected execution exception. Source code of this example you may also find in attachments to this lesson. And you can try to uncomment this line and execute an example. You would have rejected execution exception. This is because I submitted task after I called shutdown method. We'll keep this line commented for our example. You can check this later if you don't trust me. And you should never trust me, always verify everything by yourself. Check documentation and experiment with different code examples to understand the topic better. After we called shutdown, it is recommended to use another method, await termination. This method takes long value and time unit to define timeout, how long we should wait for all tasks being completed. Why we need this? You already know potential issues of concurrent programs. Deadlock may happen, or live lock, or probably some operation just takes significantly more time because of waiting response from other server, or something else. But you don't want to keep your threads and tasks working if the time exceeds. That's why we set specific timeout for our executor service to finish all tasks. Await termination method returns true in case executor terminated, and false if the timeout elapsed before termination. Await termination may throw interrupted exception because thread is waiting in this line for specified amount of time. And at this moment, theoretically, other thread may interrupt the current thread. That's why compiler makes us handle interrupted exception. So we ask our executor service to wait for 2 seconds to complete all tasks. And then finally block I call shutdownNow method. This method waits nothing and just attempts to stop all executing tasks and returns the list of tasks that were awaiting execution. We call it to make sure that our executor service is terminated. So let's review one more time. We called shutdown to stop accepting new tasks in our executor service, then we gave time for executor service to complete all tasks, and after that we try to interrupt all tasks that are executing. Let's run this program and investigate console output. Shutting down text is printed after that we managed to complete these tasks. But all other threads were interrupted, and you can see text from catch block. That proves that all tasks terminated not instantly, but in places where it is possible. So tasks will be interrupted when thread is in waiting state. And you can handle interrupted exception according logic of your program. As I already said, shutdownNow method returns list of runnable objects. This is list of tasks that never commenced execution. Basically, that's all what I wanted to share with you in this lesson. We still need to learn executor service implementations, but I believe we'll have enough time in a separate lesson for that. Now let's review what we have learned in this lesson. In this lesson we learned executor interface. Also we learned another important interface, executor service. After this lesson you can understand what a thread pool is. I explained what callable and future types are. And you saw how you can manage multiple threads with executor service. Now you know how to execute multiple tasks with the help of invokeAll and invokeAny methods, and you know how to interrupt all tasks. That's it for today. Thanks a lot for your attention, have a great day, and see you in the next lesson.